Today we will be discussing the topic forces and motion. An important equation is speed equals distance over time. If the speed of an object is changing, then it is accelerating. Acceleration is the change in velocity divided by time and is found in the units meters per second squared. Speed and time are both scalar quantities. This means that they have just magnitude, or in this case, just speed, whereas velocity and acceleration are vector quantities. All this means is that a vector quantity has both speed and direction. On the exam, there will be two types of graphs we may have to dictate answers from. The first graph is distance over time. The gradient of this graph is the velocity of the object. On the second graph, velocity over time, the gradient is the acceleration of the object, and the area underneath the line on the graph is the distance. We need to know two things. Firstly, we must know that Newton's second law dictates that force equals mass times acceleration. Secondly, we must know that weight equals mass times gravitational field strength. Springs are a good way to visualise the effect of force on an object. Hooke's law states that for a spring, force equals the spring's constant times the extension, or F equals kx. A spring will return to its shape up until a certain point. After this point, it will stretch. The gradient of an extension force graph is the constant of the spring. A couple of important equations that we need to know is the moment of an object. The moment is the force times the distance from the pivot. Another equation is momentum. Momentum is measured in kilogram meters per second and is found by multiplying the mass and the velocity. Finally, the force of an object can be found using the change in momentum over time. This is why seatbelts are used as a handy safety feature in cars. Seatbelts attach the person to the car, thus increasing the time it takes for them to slow down. The change in momentum is the same, but the time is increased, hence the force is significantly lower.